Hello student. In this video, I am going to explain chapter 16 of class 11th maths. This is the last chapter in class 11. The chapter's name is probability and this is the first video of chapter 16. As we know earlier we did probability in 9th standard, 10th standard and then we have to do it 11th standard also. So first of all, we should aware of the introductory part of this term that is probability. Now it is written here in NCERT book that in earlier classes we have studied about the concept of probability as a measure of uncertainty of various phenomena. We have obtained the probability of getting an even number in throwing a die as 3 by 6 because here the die it has 6 faces and 6 numbers are there, that is 1 2 3 4 5 6, and you all are aware of it. When you roll it you will get one number, and here it is asking an even number in throwing a die, and even numbers are 3, that is 2 4 6. Therefore the required number is 246, that is total number is 3, and number of total number in a dice is 6. Therefore, its probability is 1 by 2 that we did in 9th standard. Here the total possible outcomes, as already I told you, 1, 2, 3, 4, 5, 6. The outcomes in favor of the event of getting an even number are 2, 4, 6. Therefore, in general, to obtain the probability of an event, we find the ratio of the numbers of outcomes favorable to the event to the total number of equally likely outcomes. Here the most important term is equally likely outcomes. That means the favor of number 1 will come in a dice, that is 1 by 6, and this is applicable for all the numbers. That's why it is called equally likely outcomes. And this theory of probability is known as classical theory of probability. Okay, this is the classical theory of probability. That means what happens in classical theory of probability? When there are n equally likely outcomes to an experiment, then probability of A is equals to number of outcomes of that is favorable to A divided by number of total possible outcomes. Here, number of outcomes favorable to A is even number and total number of outcomes is 6. Therefore, as per classical approach, the probability of A is equals to 3 by 6. Since it can be reduced, therefore its answer is 1 by 2. Okay. Now, in 9th standard student, we did the statistical approach of probability where the data are given and we have to observe the data, then after answer the particular question. And that is called statistical approach of probability, or it is also known as empirical probability. Okay. So now what is statistical or empirical probability? It is determined by how often an event has been observed to occur. Empirical probability is number of success divided by number of tries. Empirical probability only makes sense if the event is repetitive. Both the theories have some serious difficulties. For instance, these theories can be applied to the activities or experiments which have infinite number of outcomes. In classical theory, we assume all the outcomes to be equally likely. That I explained earlier. Recall that the outcomes are called equally likely when we have no reason to believe that one is more likely to occur than other. In other words, we assume that all outcomes have equal chances to occur. Thus, to define the probability, we used equally likely or equally probable outcomes. This is logically not a correct definition. Then after another theory comes, that is axiomatic approach of probability. And here in 11th standard, we will learn axiomatic approach of probability. To understand this approach, we must know about the few basic terms. These terms are underlying children, these are the very important terms, and that term starts with random experiment. The second term is sample space. Then after the third one is events. And exercise 16.1 is based on these three terms. Questions are based on random experiment, sample space, and then after in 16.2 we have to find out events. Now let us learn about these all terms. What are they? Now random experiment. Random. In our day-to-day life, we perform many activities which have a fixed result no matter any number of times they are repeated. For example, given any triangle without knowing the three angles, definitely the total sum of angles is 180 degree. We also perform many experimental activities where the result may not be same when they are repeated under identical conditions. For example, when a coin is tossed, it may turn up a head or a tail. But we are not sure which one of these results will actually be obtained. Okay, then such experiments are called random experiment. So here the two cases, two conditions for a random experiment are there, and these two cases are it has more than one possible outcome. Okay, then a coin is tossed, it has two faces, head or tail. More than one possible outcomes are there for a random experiment, because if one possible outcome is there, then it is defined that that particular outcome will come. Therefore, this is not a random experiment. And the second case is it is not possible to predict the outcomes in an advance. We don't know while tossing a coin which will appear, either head or tail. Okay, that's why this kind of experiment is called a random experiment. So in this chapter, we shall refer the random experiment by experiment only unless stated otherwise. Here, then after the next term is outcomes. Definitely, if a random experiment is there, then more than one possible outcomes are there. And these outcomes, total a possible result of a random experiment is called its outcome. Whatever the random experiment is showing, it is called outcome. Okay. Now just children, just see here, consider the experiment of rolling a die. Now come to a die. Definitely it has 6 faces. When we roll it, it will give either 1, 2, 3, 4, 5, 6. If we are interested in number of dots on the upper face of the die. Okay. Then the set of outcomes, that is the die will show 1, 2, 3, 4, 5, 6. And if it is under curly braces, that means it is a defined data that we did in chapter 1 sets. Is called the sample space of an experiment. Therefore, sample space is a set of total outcomes of a random experiment. Okay. The set of all possible outcomes of a random experiment is called sample space associated with the experiment. And sample space is denoted by children capital S, because sets are always be denoted as capital S. Each element of a sample space is called sample point. Another important term is sample point. Here we started with random experiment in axiomatic approach of probability. It starts with random experiment, then after sample space, then after sample point. In other words, Each outcome of a random experiment is also called sample point. Therefore, this line is going to be underlined. Okay, so this is the basic terms that is used in exercise 16.1. Here I am going to explain one or two examples that are given here. The first example is here, the first example is yes, the first example is two coins are tossed. 1 rupee coin, 2 rupee coin. In both the coin, yes, head and tail are there. We have to find out the sample space. Clearly, therefore, the sample space is either head head, head tail head, and tail tail. Head on both the coins. Another one is one side is head, another one coin show head, another coin show tail. Another point is tail on first point, the one coin show tail, other one shows head, and both the coin shows tail. Therefore, the total possible outcomes when a coin is tossed for 2 times, it is under curly braces HH. Here HH, that means a coin is tossed for 2 times. If it is only H or T, that means a coin is tossed for 1 time. Then after comma, because all the outcomes are going to be separated by comma insets. Then after HT, TH and TT. Therefore, the outcomes of this experiment are ordered pair of H and T. Ordered pair of H and T, that means HT means the first point shows head, second tail. But TH, that means the first is tail, second is head. Therefore, here order is important. This way, we have to find out the sample space if a coin is tossed for 2 times. These kind of examples are given in exercise 16.1. You have to do all these examples. Then after we will start 16.1 in next video.